Okay, this is what we did last week, where we used the quotient property to write this as log base 7 of W6 over 5W minus 3. And this was log base 7 of 8 to the 1/3. Remember, we can write 1/3 as cubed roots. So the cubed root of 8, we said was 2. Now that canceled with that, leaving us with W divided by W plus 6 divided by 5W minus 3 equals 2. We multiplied both sides by 5W minus 3, and then you guys solved. Okay, that's what we did last week. We saw the case where you have a log base with the same base equaling a log with the same base. Now, we are going to look at cases where you have log equaling a number, okay? So, we're going to do something like this, where your log or natural log are on the same side. Last week, they were on opposite sides, so you could cancel them out and then do the algebra from there. Today, we're going to see cases like this. So we're going to continue to use the properties. So the first property I'm going to use is the power rule. So this 1/3 will become the power to the 27. So this will be natural log of 27 to the power of 1/3. This can stay the same for now. Okay, now remember, how can I write powers to the 1/3? How can we rewrite this? Yes, the cubed root of 27. And what is the cubed root of 27? 3. So guys, we can rewrite this as natural log of 3 plus the natural log of x minus 5 equals 4. Which property will I use next? Yep. What else do we call that? Product. So we have an addition sign, so we're going to multiply like you said. So I'm going to do 3 times this stuff. So this will be 3 times x, which is 3x, and 3 times a -5, which is -15. So we just use the product property. Okay, so let me show you guys the rule here. The rule is whenever you have a natural log, I'll just put natural log of x equaling any number. I'll put 4. Doesn't matter what number this is. Once we reduce this down to where the natural log is by itself, we are going to turn this into an exponential problem. So what we have is e to the ln of x equals e to the 4. What this does, exponentials and natural logs cancel out, leaving you just with x. So your answer is x e to the 4 for this case. We're going to do the same thing over here. Whenever I have a natural log, we're going to make it e to the power of natural log. This is e to the power of 4. Okay, so this will cancel out. We have 3x minus 15 equals e to the power of 4. You guys can use a calculator to figure out what that is. You can get calculators later. So I'm going to do e to the power of 4. That is 54.5982. All right. And then we're going to add 15. So we'll have 3x equals, this will be a 95982. 54 point all of this plus 15 would be this. And then we're going to divide by 3. So let me tell you what that is. So add 15 and divide by 3. You'll get 23.1994. All right, let's do one more example of these. We'll do one where it's not a natural log. So let's do this one next. Okay, again, guys, we're going to use our properties here. I'm going to use the quotient property. So this is going to be log base 2 of c squared divided by 3c minus 5 equals 2. Now, whenever you have a log with the base of x equaling anything, I'll just say 7. What you're going to do here is you're going to make the base what you're raising it to. So this will cancel out. What is our base here? A 2. So what I'm going to do is I'm going to make this 2 to the power of log base 2. 2 to the power of 2. So this will cancel out. What we're left with is c squared divided by 3c minus 5 equals 2 squared, which is 4. And then you solve. So I'm going to multiply both sides by 3c minus 5. 3c minus 5. I'm going to come over here. I get c squared equals 12c minus 20. We're going to have to factor here. I'm going to move these items to the other side so that my signs will change. I'll have c squared minus 12c plus 20 equals 0. From here, we're going to factor. So let's think of what numbers we'll need. I need two numbers that multiply to 20 but add to negative 12. Yes, y'all got it. If you multiply these two together, that'll give you 20. If you add them, if you add them, you'll get negative 12. So negative 10 and negative 2 are your factors. So this will be c minus 10, c minus 2. And then you equal them both to 0 and solve. So c minus 10 equals 0, solve it. C minus 2 equals 0, solve it. So we'll get c equals 10. We'll get c equals 2. Okay, let's do one more example on the same page. One more example, and I'll let you go. All right, so here, I don't have any other logs to do the product rule with. So what I'm going to do here, I'm going to do some algebra. Subtract 4 from both sides. We're going to get 2 times log base 9. All of this equals 1. What I'm going to decide to do is divide by 2. So I'm left with log base 9 of k squared plus 2k equals 1/2. We're going to change this to an exponential problem. How do I change it to an exponential problem? Okay, do it on your own paper and solve. I'll be walking around. Just a reminder, guys, log, what's the answer? 2, because 3 squared gives you the 9. If you want to write this as an exponential, you do 9 to the 1/2 power gives you that. 9 to the half gives you k squared plus 2k. That's where that comes from. Now, if you want to, just go ahead and do the 9, cross it out. 9, and you have that. Same thing. Okay? How do you rewrite half powers? Yes, so this is a square root of 9 equals this, k squared plus 2k. So this is 3 equals k squared plus 2k. Move this 3 over, make it a minus 3, and then factor. You need two numbers that multiply to negative 3, add to 2.
3.
Perfect. 3 and negative 1. So your factors are k plus 3 and k minus 1. So we get k equals -3 and +1. Okay, will that work? We need to plug these in and make sure we don't get any negatives. So if I plug in a -3 right here, -3 squared is 9. Plug in a -3 here, I get -6. Okay, I got a +3 inside. So this works. And I'll get a positive number inside. Okay, so these are both solutions. You need to make sure that when you plug those numbers back in, you don't get a negative inside of here, because you cannot have a negative inside of a log. You cannot have that. So make sure to check for extraneous solutions.